So, part 2 of equable shapes. So remember, an equable shape is when the area is the same as the perimeter. So what we did in part 1 is we focused on rectangles and we fixed the length of our rectangle to be 3 centimeters. So we were trying to be very systematic. So if you remember, this is what we did for the first one. And we can see the areas here, and we can see that we did find one. Okay, 3 by 6 gave us an equable shape, and it was actually an equable rectangle. Now, what we want to do now is we want to be able to show that this is the only equable rectangle where there's a length of 3 centimeters. Right? In other words, if we carry on 3 by 8, 3 by 9, 3 by 10, we're not going to find another one. Now, I think the best way of doing this is to draw a little graph. Okay, we can do a little diagram for ourselves. So that's what we're going to try to do. So you're going to need pencil, going to need ruler. So what I've done here is that I've already set out for you just here. I'm just going to make my picture slightly smaller so you can see a little bit better. I just need to take that up a little bit more. There you go. Right, so if you look at mine here, look, you can see I'm just about to plot these. Now my y-axis, I've gone up to 21. Why have I gone up to 21? Well, I went up to 21 because that will allow me to plot this figure here. And going across the x-axis, I've gone across to 7. 1, 2, 3, 4, 5, 6, 7. Because that will enable me to come and plot all of these different rectangles. So I'm going to show you now. So the first thing is to make sure that you've drawn your axes. Okay, you can see mine just here. All right. Now I'm going to plot the first one. So a 3 by 1 has an area of 3 and then a perimeter of 8. So it's got an area of 3. So if I just do the areas first, it'd probably be easier. And then for 2, it had an area of 6. So I'm going to plot that. And then for 3, we've got an area of 9, and then it goes 12, 15, 18, 21. So I'm going to plot the other points on. So 3 goes with 9, 4 goes with 12, 5 went to 15, 6 went to 18, and 7 went to 21. Now I'm going to do, let's join those together. Right, so we've got the area line. So that's area. Oh, wait a minute. What would the area be if the width was 0? It'd be 0, wouldn't it? So why not go all the way down there? Let's go down there. Go all the way down. One nice straight line. Okay. So that's the area. And now I'm going to plot the perimeter on the same diagram. Let's plot the perimeter. So the perimeter will be, so for 1, it was 8. It was 10, 12. So for 1, it went to 8. And then 2 went to 10, 12, 14, 16. So it's going up in 2s, isn't it? This time I'm not gonna go all the way down here. You can have a little think about why I'm not going to come down there. So 3 went to 12, 4 went to 14, 5 went to 16. Look, it's getting closer to the line, isn't it? And then the last point. Now I'm actually going to draw this in a different colour. I'm happy about where those are because I just want it to show up a little bit better. So I'm going to come and draw my line there. You can just think about why I've not connected this down here. All right, just let you have a little think about that. And then we've got, so that's the perimeter. And that's the equable shape, just there, which was 3 by 6. Now the beauty with this diagram is it shows you, look, the areas are following a nice pattern this way. We change the colour and we can have a nice different colour on there. The area are going that way. Perimeters are going that way. So they're not going to join each other again, are they? They cross over nice and neatly here, nice intersection point here. But they're going to keep going on different paths. They're never going to join again, are they? They're never going to meet each other again when the length is 3 centimeters. So what you should be doing now is you're going to do something very similar with, if you remember what we did next, is we drew up a table for a length of 4 centimeters. And then we did the same for 5 centimeters. But 5 centimeters, remember, was different, wasn't it? Because we didn't find one that was the same, so we had to explore the decimals. So it was a little bit harder to do. And then you should have gone on and done 6, 7. There's nothing stopping you going and doing some more. See what you notice. Let's look at the diagram for 5. Remember, you can pause this, you can have a go yourself. Good use of doing this is to keep pausing it, try stuff yourself, and then play me some more. Okay, so what I've got here, just look at how I've drawn this first, drawn the axes. So I'm gonna do this one. Remember, you've got to do 4 first as well. Okay, I haven't done that one for you. You can do that one. So if I've got a fixed length of 5, if you notice on my y-axis for area and perimeter, I've got mine. Whoops. So you can just see it goes up to 25. The reason it goes up to 25 is because I want to be able to plot this on there. And then it's going to go across to 5. Goes across 5. Right, it goes across to 5. Notice where I write the numbers as well. They're not sitting on top of the lines. They're kind of through the lines. Okay. So I'm going to quickly draw this one. Let's do the areas first. So the areas go, so 1 goes to 5, 2 goes to 10, etc. So we can do that. Remember, you can use calculators if you want to. That's fine. So 2 goes to 10, 3 went to 15, 4 went to 20, oops, on there, and 5 went up to 25. Connect them together. So for area, you can go back to the beginning. I'm just going to leave this one because it's not particularly important there, going back. And now we're going to plot the perimeters. So let's go back and plot the perimeters. They go 12, 14, 16. So they're going up in 2s, but starting at 12. So I'm going to start at 12. So 2 goes to 14, 16, and 4 went to 18, and 5 went to 20. Okay, let's just pop this in a different colour so we can see it a little bit better. And plot these as best we can. So those were the perimeters, and we had just a second ago, we've got the area just there. And then the solution was, remember, this was the equable one, but the problem with this one, is that it's not a nice whole number, is it? So it's going to be 5 by, and you can read it off of here. Now you've already explored a little bit here, but I can see it's going to be 3 point something. Now we've already done that from the table. If you remember, we looked at the table, didn't we? And we explored these numbers inside. And then we found that was really close. And then we said also you could even explore further. Right? You could break it down even more. So there's lots of ideas there for you to do. So remember, I'm expecting you to be carrying on with, after you've done your table for 5 and 6 and 7, but there's nothing stopping you doing a few more. 8, 9, 10 would be sensible. You don't have to carry on indefinitely. But then for some of them, not necessarily all of them, but for some of them, draw me a graph to show me that these two lines are hopefully going in different directions. And the idea behind that is that they will not come back together again. So when I've got a fixed length of 5, that's not going to happen again, is it? We're only going to be this solution. 3 it's 3 point a bit. All right, looking at that. And obviously we open up the table, don't we? Look at the table to explore that further. So hopefully there's some ideas about where you should be taking this work. So let's keep going. Have a go.
If you enjoyed that video, please like and subscribe or leave a comment down below. Thanks for watching. I've been RMS Maths and I'll see you next time. Maths out.